Good morning or good afternoon, everyone. Thank you for joining me for REMI's training series on its 4 softwares. I'm Leon Zhang, an economist at REMI, and today I'll be showing you REMI's TranSight model, which is what we use to analyze transportation-related policy and projects. So before we begin, this webinar will last for 1 hour. We will try to end at exactly 3 p.m. How is everyone's audio? Is anyone having audio issues? Okay, I don't see anyone saying they have audio issues, but can everyone hear me? All right, let's get started. So a quick overview of what we're going to be discussing today. So first, I'll be talking about REMI in general. Next, I'll be talking what TranSight offers on top of what REMI's flagship software PI Plus gives. Next, I will give a demonstration of TranSight and show you the kinds of analyses we can do both in REMI's software in general and in TranSight in particular. And finally, I'll try to leave a little time at the end for Q&A. If we run over time and there are questions that are still unanswered, you can always reach me by email at leon.zhang@remi.com. So first, let me tell you about REMIs. So the main thing we do is provide software for economic analysis. So we have 4 main packages for doing this economic analysis. So we have PI Plus, which is our flagship model and is used for general policy analysis. Next, we have TranSight, which is what today's training webinar is specifically for. And that deals with questions related to transportation, such as building a new rail or building a new highway. We have Tax PI, which is for dealing with questions related to fiscal issues and budgets. And finally, we have E3 Plus, which stands for Energy, Environment, and the Economy, and it looks at questions about energy. And our clients perform various economic analyses using these 4 models. In addition to software, REMI provides unlimited technical support. So if you choose to use the software, you're not left in the wind. We'll help you through every step of the way. And finally, we can also do the economic analysis for you. If your staff is overloaded or you don't have the technical expertise, we can certainly help perform the analyses on our end. To give you an idea of the kinds of questions that we look to answer, so any economic policy can affect multiple macroeconomic indicators such as employment or output or personal income. So these models all are able to forecast the effect of what a change in policy or what a natural event in the case of resiliency, how these can affect these various economic indicators, as well as many more economic indicators that are not listed here. And we can also look at how these impacts affect different demographics across 101 age cohorts, 4 ethnicity cohorts, and 2 gender cohorts. REMI's model has 4 components. It's the main workhorse of the REMI model is its input and output, which looks at the interplay between different industries, between different regions, and how they interact with each other. On top of that, there's a general equilibrium component, which looks at prices, how consumers choose to spend their money, how consumers choose to consume, how firms choose to hire workers, set wages, set capital, all of that. Finally, there's the econometrics portion, which looks at estimating multipliers and elasticities. Finally, there's the economic geography component, which looks at the effects of how geography links with labor and industry. And all these put together form the dynamic model that is the REMI model that looks at, that is an integrated economic modeling approach. Now at the bottom you see are various clients that use our software for various analyses. So the main methodology of REMI's model and what I will be demonstrating later today is we have forecasts of baseline value, and REMI's model will iteratively and dynamically compute an outcome after a policy for up to 40 years in advance, up to 2060. And so you can see the forecasted effect of the policy on many different variables for a very long horizon. So let's get to talking about TranSight in particular. So there are 2 main ways that improving or changing transportation infrastructure affects the economy. So the first is that if your roads are better, or there's more roads, it's easier for, say, your trucks to get into a city or out of a city. And so this goes to the industry aspect of transportation. It's easier for firms to get their materials, which means cheaper materials. It's easy for them to ship out their finalized goods to their vendors, so that means final lower consumer prices. The second aspect deals with labor. So if it takes shorter to commute, then the number of workers that a firm has access to is greater. And on the other side, if your expected commute time is less, then there are more companies that you could be conceivably working for. So this means access to improved labor pools, or access to jobs that might be a better fit for you than whatever you currently have, improves the quality of labor markets, which improves productivity, improves quality, improves, and as the final step, improves output, improves GDP. So TranSight specifically looks at questions of transportation projects, transportation policy. So we specifically try to model how these changes are going to impact the economy as a whole. And we take into account various factors, not including but not limited to emissions factors, fuel and fuel efficiency. So a quick overview of how the model works. So we start with a travel demand model. So a travel demand model is going to include aspects such as vehicle miles traveled, or vehicle hours traveled, or number of trips taken by vehicles. The next part looks at what measures of effective distance, effectively how far a worker is from his job, or how far the final store that a good will be sold at is from the factory. And so this is going to entail transportation costs, it's going to entail commuting costs, it's going to entail accessibility costs. And one reason that we care about these, for the immediate present and the immediate future, you can look at, say, the effect of work from home, because work from home can be modeled as essentially dropping these costs to zero. So if you want to ask how work from home is going to affect the economy, this is one way to get at that question. And so integrating the travel demand model and measures of effective distance on top of other macroeconomic analyses is going to lead to forecasts of the effects in employment, in GDP, in income, in migration. So what are various metrics that we look at and that we can put final analyses on? So we can analyze construction spending, we can analyze operations and maintenance spending, and factors we take into consideration are access to inputs, access to labor, how efficient a network is. And this analysis can be used to look at financing. How should you finance your new highway? What do emissions look like if your transportation network is improved? What does fuel consumption and fuel efficiency look like? All these types of questions can be tackled using TranSight. Just as an example of why it's important to understand the benefits of forecasting the economic effect of, say, constructing a new highway. So, you have your upstart construction costs. It'll take maybe 4 years to complete the highway. And you want to ask what's going to be the economic impact of building this highway. It starts off being costly, and year on year, you'll get more and more, you'll recover more of the economic cost in terms of increased efficiency, increased employment, increased output. And these kinds of improvements tend to build up on each other. So improvement in the present will build up on itself and become even greater of a benefit in the future. These are just more of the applications of what is possible in TranSight. So you can do long-range transportation planning. You can do studies on corridor, freight, and highway. You can perform analyses on transportation improvement programs. You can do cost-benefit analysis. If you have various transportation policies that you might want to implement, but you can't implement all of them, TranSight will help you rank various policies based on certain criteria that you can supply. And So these are just some of the applications of TranSight. So now let's get into the model. So when you open any of REMI's models, you'll be greeted by a screen that looks something like this. So on the right, you see a bunch of buttons for national forecasts and simulations and controls. And on the left, you see buttons for simulations, controls, and forecasts. And all of these are vital to the underlying calculations that are working in REMI. So, constructing a new national control is going to let you have a baseline in order to compare what the forecast after your policy is going to look, how it's going to compare to the current baseline. A very important aspect, obviously, is this new regional simulation, which is the module where you actually go and calibrate the inputs to reflect the kind of policy you have in mind. So each model is built specifically for each client. You can see here, I have a model for the Houston-Galveston area. You can have, so each model is built up by region. By default, each region can be as small as a county, and regions can be merged to as large as a state itself if you want. Here, this particular model has two regions, where one region is the Houston-Galveston area, and the second region is the rest of Texas. Each model, depending on the model, can have anywhere from around a dozen to 160 industry sectors. You can see this particular model has 70 sectors. All right, and now let's get into what we can do with the REMI model. So first, I'm going to show you an example of what we've been doing for analyzing the impact of the economic impact of COVID-19. And so what we've been doing is we've been comparing a macroeconomic forecast based on macro forecasts from this year. So in particular, we have access to the University of Michigan's research seminar in quantitative economics. They've been putting out monthly macroeconomic forecasts to look at the forecast, what the economy is going to look like, accounting for COVID-19. We also have a pre-COVID national baseline that's based off of what forecasts had looked like last year. And so in general, we have a variety of macroeconomic settings that you can toggle. So we have, you can see here, we have forecasts from the RSQE for various months. We have a pre-COVID forecast. And in times that are less turbulent, we have baselines for medium, high, and low GDP growth. So these are, and then suppose you have your own forecasts from your own source. It's very easy to supply your own macroeconomic forecasts to the software. And you can save this as your own macro values forecast. And so the kind of output that you can do with looking at the national forecast is, for example, you can look at on the national level what the impact of something like COVID-19 was. So you can see here, I've compared the May RSQE forecast, which again is accounting for the economic impact of COVID-19. And it is being compared to a pre-COVID baseline. So here you can see the effect on employment. It's forecasting an 8% net drop compared to a non-COVID timeline for 2020. And it's forecasted to continue to be behind for the near future. GDP is also forecasted to be behind because we had a very sharp drop recently in GDP, and it's going to take a while for it to catch up to what GDP would have been without COVID-19. So we can look at more detailed economic impacts. So for example, let's look at output. One thing that comes out is, like I mentioned before, we have many industries and many sectors that we can account for in these models. You can see some of them on the left. We have forestry, we have oil and gas extraction, we have utilities, we have construction, a lot of manufacturing and transportation, and so on. And we see here some of the more affected industries from COVID-19 are, say, manufacturing, tourism, food services and drinking places, and then healthcare, because a lot of healthcare places are not able to work as usual because a lot of patients are putting off their temporary care, taking into account that COVID-19 is going on. So these are the kinds of economic analyses that can be performed on the national level in REMI software, and the same exact analyses can be performed at the regional level. So, since every model has a specific region in mind, we can build a regional forecast on top of every national forecast. And we can look at the same numbers and compare. Your total employment here drops about 9%, GDP drops about 6.2%, and we can say these are perhaps higher numbers, higher drops in Texas compared to the nation as a whole. And if we look at what the industry level impacts look like for this particular region, here we ask what got hit hard. Again, a lot of manufacturing, a lot of food services and drinking places, construction. And so REMI, as you might expect, we've been doing a lot of support with clients about working with them, about forecasting what COVID-19 is going to be affecting, what effect COVID-19 is going to have in the present and in the future for their regions. And so this is an example of the type of analysis that can be done in any of REMI's models. So any of REMI's models is going to have these buttons in front. It's going to let you choose a national baseline. It's going to let you choose, it's going to let you run a new baseline and perform comparisons and run simulations. So now I'm going to talk about specifically what TranSight has built on top of the standard PI Plus model. So every forecast screen is going to have these modules on the right. And you can look at model linkages. REMI's model hinges on 5 main blocks: an output and demand block, a population and labor supply block, a labor and capital demand block, a market shares block, the compensation prices and costs block, and various policy variables that are linked to these specific blocks. There's a lot of interplay between these blocks, and there's a lot of interplay between the policy variables that comprise them. And so a list of policy variables that come in every REMI model. For example, you can look at compensation, you can look at economic migration, you can look at employment, you can look at fuel costs, you can look at output, and so on. These are all policy variables that you can analyze. You can model your policy as a change to one of these policy variables. And you can run your forecast to, again, up to 2060 if you want, and you would be able to see the effect of that policy. What TranSight adds on top is specifically modules and policy variables related to transportation. First let's take a peek at this travel demand button. And so a travel demand model is going to incorporate vehicle miles traveled. It's going to incorporate vehicle hours traveled. It's going to incorporate trips made. And so you can choose to, if your region has a if your region has its own travel demand model, you can input that model. In general, you can supply your own numbers manually as needed. All of these variables are, if you have them, they will greatly help you understand economic impacts. Additionally, you can include as policy variables. These are just some of the policy variables related to highway constructions. What kind of capital you have to work with is very important on how well your highway is built. Exogenous final demand for technical services, demand for construction employment. These are variables, policy variables that you can model your construction project using. And other policy variables related to operation maintenance, related to government funding. You know, is your highway going to be funded from the sales tax? Is it going to be funded from a property tax? Is it going to be funded from the gas tax? You know, questions of how you're going to fund your highway are important. You know, where your funding comes from can have different implications on what your state's budget is going to look like. And earlier I mentioned effective distance. So there's, you know, a couple ways to think about effective distance. If you're a worker and you need to commute every morning, your commuting costs is going to be a big factor in how productive you are. And then if you're if you're a company that produces goods, transportation costs is going to be important for you, because again, the better the transportation infrastructure is, you know, the more output you can produce. And so these are, so accessibility, commuting, transportation are various ways that you can think about what is the effective distance from point A to point B, where point A could be the worker's house or the company's factory, and point B could be the store or where the worker works. So for today, you know, I've given an example of a kind of simulation that you might want to run in TranSight. So here I am modeling the effect of introducing a new high-speed commuter rail to an area. So you know, we can say that this rail would, say, improve commuting costs, accessibility costs, and transportation costs by some amount. And on the flip side, you know, it'll take 4 years to build, and we are putting in, you know, $50 million per year for 4 years into the construction industry until the project finishes. You know, let's look at what the simulation gives. So first, we see increases in employment. So about 800 jobs per year while the highway is being built. And coupled with this increased employment is also an increase in other macroeconomic indicators. So we have an increase in population, we have an increase in GDP, we have an increase in output, in income, and so on, while the highway is being built. And after it's finished being built, you know, we see even higher increases in employment, 20,000 new jobs, because it's easier for workers to get here and there. And it's with companies having more output, they're making more money, they can afford to hire new workers. So the increases we saw just from highway construction, you know, they were notable, but compared to the increases in economic activity after the highway is completed, and obviously once it's finished, there's a lot more economic impact. And we see there's a lot more employment, there's much higher GDP, a much higher personal income, higher labor access, and so on. And so, let's look at a deeper dive into the simulation results. So, let's take a peek at more output. You can see here, at the start, we put in $50 million per year into construction. And it's actually forecasted that there's more than $50 million of outputs as a result of this investment. On top of, and this is because investment in itself inherently has this positive feedback loop that generates output. And then in addition to increases in output from construction, there's also increases in output from technical, scientific, and professional services, because they're going to be helping out with the highway construction, increased real estate, increased retail, increased output from food services and drinking places. And this is while the highway is being constructed, or the rail is being constructed. And after the rail is finished, we see even larger increases in output. Again, more construction output, more real estate output, more retail output, and so on. On the demographics side, we saw increases in population on the whole. Let's look at, what it looks like by age. And so what I'll do here is I'm going to aggregate, we have 101 age cohorts. I'll aggregate them into 4 major age groups so it's easier to see what's going on. And you can see population increases, with the most notable population increases coming from the age 25 to 64 bracket. This is because one of the advantages of improving transportation infrastructure is in better access to labor. And so with better access to labor, the people that are going to come and move and migrate to your region are the ones who are working age, so age 25 through 64. And so this is an example of the type of analysis that can be done using TranSight software. So, we can simulate the construction of a new rail and analyze the impacts of what that policy is going to have on the economy, and we can look at it on whatever scale we want. Effects on employment and population, effects on GDP and output, effect on personal income, and so on. And this difference, you can see that it's just a difference that grows. And finally, this is new. You can see we're in TranSight version 4.4, and this is new to version 4.4, the studies module. So I'm not gonna give an example of this today, but what the studies module allows users and clients to do is to run many different policy simulations at once. And then after the policy simulations are done, they can compare the policy simulations on various metrics. Do you want the greatest employment increase? Do you want the greatest output increase? Do you want the greatest GDP increase, and so on? And so the studies portion is going to allow you to run all these possible policies and rank them according to whichever output variable you deem is most important. All right, and so that's a brief look at REMI's software. Today I've introduced you to what REMI's goal and what its REMI software is meant to do. I've told you what TranSight, why we have TranSight, what we can do in TranSight, and I've shown you examples of economic analyses you can perform using any version of REMI's various models. I've done as an example of that, a COVID impact analysis, and I've shown you what TranSight has on top, which is analyzing this effect of a new commuter rail. And with that, now I open it up to questions. Okay, so I have a question from Sheng Li. Is this an agent-based model or is it a systems dynamic model? Right, so like I mentioned earlier, the model is based on 4 components. So there's an input-output model, there's a general equilibrium portion on top of an econometric and a behavioral and a geographic component. So the input-output model and the general equilibrium model, which are kind of the workhorses of the model, are you can think of the input-output portion as a system dynamic, as a system model that isn't necessarily dynamic, it's more static. However, the general equilibrium portion is dynamic, and how it looks at consumers, the underlying modeling equations are kind of micro-founded on agent-based behavior. I have a question from Isabel Victoria. Do the REMI sector/industries align with NAICS codes? Yes, exactly. So the industry sectors are based initially on the 4-digit NAICS codes, and they can be broken up as needed. For example, in the E3 plus model that looks at energy, we break up manufacturing into a lot of different manufacturing components. So the E3 plus model, for example, ends up at 160 sectors, around half of which are manufacturing. But yes, to answer your question, the REMI sector/industries do align with NAICS codes. I have a question from Catherine Chalmers. Are the regions based on MSAs? So the base region is based on at the county level. We are able to, we can aggregate regions to, as we saw in this demonstration, to a metropolitan area plus a state. It's also possible to go down into a finer region, although that requires a lot more legwork, and models constructed at that level would tend to be more expensive. I have a question from Isabel Victoria. Can I import my travel demand model outputs, VMT and VHT, for passenger cars and trucks into REMI? If so, can you show how to do that? Sure. So I think I might have showed this, but I think there's no harm in showing it again. So if you have your own VMT and you have your own VHT, you can import those numbers. Alternatively, you can choose to import the data manually. And so here, you mentioned passenger cars and trucks. This drop-down menu has autos and it has trucks. And for each auto and truck, you can enter whatever number you want for VHT and for VMT. And this is where you would enter these numbers. I have a question from Isabel Victoria. For transit, what are the transit stats to be inputted into the model? Right, so here, again, we're calling them VMT and VHT, although I think they're going to be the same as the PMT and PhT that you mentioned. And so the various transit modes we have include passenger trains, light rail, and buses. I have a follow-up question from Victoria. Can I import an Excel file with VMT and VHT? So yes, you can import, you see here default CSV. It is possible to import data as a CSV. And obviously as well as other file formats. I have a question from Andy Blank. Can TranSight be used for modeling waterway projects? Yes, as long as it's going to be a transportation related project, and as long as you can just figure out what variables are going to be affected. You can input them as the policy variables. So I had a later question that asked, can you please show how you input data for simulation? So I'll show you that. So if you think your waterway is going to affect effective distance, you can say, I think it's going to affect transportation costs. So in the previous menu there, you would hit the effective distance button. And then as a policy variable, we'll change transportation costs. Various options we have, let's say the origin and the destination are both the Houston-Galveston area. We can add to editor and edit these values. And then, I can I can input whatever values I think my policy is going to have. And so this would be an example of we just input this policy variable, and we can repeat the same for whatever inputs we want. Let's look at access and productivity, what policy variables there are in here. If you think the new waterway is going to improve labor access, I'll just pick any industry here, oil and gas extraction, and yeah, so this is how you would go about inputting changes in policy variables into the model. And so I hope that answers both Andy Blank, your question about modeling waterway projects, and also Sajid Noor, your question about inputting data for simulation. Question from Isabel Victoria for transit economic analysis. Can I input information related to distribution of riders by household income? Alternative transportation modes riders would use in the absence of transit. So for the second part, yes, the we have various ways of transit. So there's passenger train, light rail, bus, in addition to the highway. Are these the alternative transportation modes you have in mind? And so for information related to distributions of riders by household income, I am not sure about that particular question. If you like, I can ask one of our programmers about that, and I can get back to you with an answer about that question if that's all right. And so I see a follow-up question. You see one. Okay, so let's say for auto, I'm gonna put in 30 miles here, and then I can swap to trucks. I can put in 40 miles here, so I can swap between sets of numbers, for cars and trucks. I have a question from Molly Trueblood. I have heard that REMI outputs should be considered as estimates only and not necessarily policy determinants. Can you give some examples of the best kind of language to use when discussing REMI outputs with policymakers? Sure. So again, the main thing we do is we try to give a forecast of what the economy is going to look like if there's a policy that gets implemented, and what the economy would look like if it had not been implemented. So these numbers are going to be, you can say, this policy would, has a forecasted, X% effect on GDP. This policy has an X% impact on the output of this industry. And so you can say, these are estimates of, these are estimates of what the policy is going to do. And, yeah, so if you're discussing REMI outputs with policymakers, REMI comes out with a lot of concrete numbers and also a lot of pictures and graphs. So you would want to talk about the forecasted percent changes or the forecasted differences, and also the visually they can see these changes. So I have a question from Jisong Chung. In your waterway example, what is the unit of the effective distance policy variable? Sure, let's hop back over to that. Right, so the units here are in proportion. So like what proportion of your commuting costs get chopped down? So like, this proportion being like 0.1, 0.1 would say my commuting costs get cut down by 10%. So I believe I've gotten through all the questions. Are there further questions? All right, thank you everyone for attending today's training seminar on REMI's TranSight model. Next week, we will have a training seminar on REMI's tax PI model, which is for looking at questions related to budget and fiscal matters. And in 2 weeks, we'll have a training seminar on E3+, which looks at questions related to energy and the environment and how those policies are going to have economic impacts. Thank you so much, everyone. Have a very nice rest of your day.